Hi students, welcome to Karnataka KCT and Boards. I am Diksha Kaushal, your chemistry master teacher. And namaskara, namaskara, namaskara. So how are you all, everybody in the chat box? So in today's lecture, we are going to do top MCQs from chemistry section, right? So you have already done biology section with Baswa sir. And now we are going to do chemistry section. So are you all excited? Because I want to see in the chat box your A, B, C, D. What is the answer? I want to see that in the chat box, right? So this is basically on the basis of your midterm syllabus. We are going to see your MCQs, right? Most of the MCQs, if you're finding it tough, right? If you have marked the correct answer, then that's perfectly fine. If by chance you have not marked the correct answer, right, and you're confused regarding that, so I will explain everything here, right? Regarding that question, I will explain, and the questions that I have picked up here are very, very, very important questions. Okay, so now let us start the session without wasting any time, starting with your first question on your screen. Yes, students, be active in the chat box. Yes, Pooja, Rohan, Dev. Yes, to use proper mic, if we put headphone, sound will come in only one side. Hope you will see. Guys, that's a proper mic only. Yeah, that's a proper mic only that I am using. Okay, that's perfectly connected. Okay, so that's a studio mic only. So yes, Mahesh, Dev, Rohan, Pooja, Shagu, Vinay. Okay, so now let us start the session without wasting any time, and a quick way we are going to start this session. First question is, which of the following binary solution form azeotropic mixture, right? They're asking you about the azeotropic mixture. So for azeotropic mixture, you should know two things. That in azeotropic mixture, we mix two things which have different boiling points. And when we mix it, they will have the same constant boiling point. The mixture will have a constant boiling point, right? So the mixture is going to have a constant boiling point when we mix two things here, right? First thing about azeotropic. Second thing is, when we talk about a positive deviation, non-ideal solution are of two types, positive and negative deviation. When we talk about positive deviation, that is your minimum boiling azeotrope, right? And your negative deviation is maximum boiling azeotrope. Now, if you want to just cram it, you can just cram it. If you want to understand the concept here, I am here to tell you the concept as well, right? Because my way of teaching is never, I don't want my students to just cram things here. Right, so just very simple concept it is that why ma'am positive and minimum boiling. Now understand one thing, that what is exactly boiling point? Boiling point means that when your vapor pressure of that liquid, for example, I am a liquid, when my vapor pressure will become equal to the atmospheric pressure that I am living in that case, I'll say, yes, I have achieved my boiling point. For example, your target is to have 90% marks, 95% marks, 99% marks. That's your target, right? So you're thinking, I want to crack 99% marks in your board exams. Now, that's your thought, right? But right now, you are feeling that maybe I am at 70%, maybe I am at 75%. So this is your level, and this is the level that you want to achieve. So you want to crack this level. This is the kind of jump that you need to have to crack that thing. Same as with the vapor pressure. Now vapor pressure of liquid is this. This is the atmospheric pressure. So it has to crack this jump to achieve the boiling point. When the vapor pressure will be equal to the when the vapor pressure of the liquid will be equal to the atmospheric pressure, then we will see it has achieved the boiling point. Now, when we talk about a positive deviation, what do you mean by a positive deviation? In a positive deviation, vapor pressure increases, right? We know that in positive deviation, your PA is greater than, it does not follow Raoult's law, right? So it is greater than P0A XA. That is in the positive deviation. That means if this is your cutoff, if this is your goal, this is your dream, right? And you are right now here. with the help of Diksha ma'am, you are right now slightly within few days, I have made you here, right? Then this was the level that you were, this was the difference that you had from your dream. But now as your pressure has increased, so the difference is less. That is why I am saying the boiling point has decreased, because the difference has decreased, right? That is why we have written minimum boiling point here, right? Now if you talk about the negative deviation, simple. Negative deviation means your P is less than P naught A and chi A, that is your mole fraction, right? P is less than P naught A chi A, right? Now you have less than, for example, this is your atmospheric pressure, that is constant, atmospheric pressure is fixed, right? I am at this level, for example, you are at this level right now, and because of some bad company, right, you have some friend who is just distracting you again and again. So you are now right now in a bad company. Your vapor pressure has decreased. Initially you had to cross this level, you were at 70%, you have to jump from 70% to 95%. Right now, because of your friend, your vapor pressure has decreased, your focus has decreased. Now you are at 60%. Now it's more jump that you need to have, right? That is why we are written here maximum boiling point, because here the boiling point has decreased, here the boiling point has increased. Understood? Why I have told you the whole concept behind that? Because they can ask you what is the minimum out of this, which is a minimum boiling point azeotrope, which is a maximum boiling point azeotrope. So always remember that if all the examples that are true for positive deviation are also true for minimum boiling azeotrope. All the examples that are true for negative deviation are true for your maximum boiling azeotrope, right? Now, let us see benzene and toluene, everybody. Now, because benzene and toluene, now there are two kind of solution. One is ideal, one is non-ideal solution. Ideal solution, right? Ideal solution, the two components that you are mixing are almost similar to each other. For example, this benzene, right, is similar to this toluene, right? They are approximately similar to each other only, right? So we can say that this is your ideal solution. You can write here, this is your ideal solution. What about water and nitric acid? If you talk about water and nitric acid, right? So water and nitric acid, always remember that whenever you have water with any acid, it is going to show negative deviation, right? Reason being, what is the reason? Because in positive deviation, you can, where should you write? Okay, in positive deviation, AB interactions are less than AA and BB interactions. But when we talk about negative deviation, here AB interactions are greater than AA and BB. Now, ma'am, how can you just say this, ma'am? Please explain, ma'am. Okay, I'll explain also. Now, positive deviation means, students, yes, be active in the chat box also. Why? Don't be, be active, whatever you know, try to write it down in the chat box and don't make the class boring, okay? Don't make the class boring. So now, positive deviation, here I am saying the interactions are less. Let's assume that you and your best friend, you were sitting alone, yet you were studying, you were focusing, 100% focus is on like, I want to have 99%, right? 100% focus is there. But then your best friend come. You are like gossiping with each other, you are interacting with each other. Your interactions has increased. Because your interactions has increased, that is why you are showing negative deviation. You are not able to study because you are too much into gossiping and all of that stuff, right? So this way you can remember this thing, right? Next is your AA. Now, next is your positive deviation. For example, you are studying alone, right? You are sitting there, you are studying. Someone came and you are like, I don't know this person, right? This person will not have any effect. For example, any topper is in front of you. Oh my God, this topper is studying too much. I have to study also. I need to beat this person, right? So, for example, the interactions are less. That means you see your competitor. You see the topper of the class. You would want to study more. You want to compete more, right? So, that is your positive deviation. That means you are getting motivated out of it, right? Okay? Okay? Ma'am, BP means boiling point, okay? This means boiling point. I'm writing it here. BP means boiling point. Boiling point, beta, boiling point. Right? Now, here as you can see, water and nitric acid, right? Water and nitric acid. What is a water? Water with nitric acid, it will cause more interactions. Interactions will increase. Why the interactions will increase? Because earlier this is an acid only, it is a one molecule, but when we add water into it, it will dissociate into ions. Ionic interaction is more stronger than covalent interaction. That is the reason here you can see that here there will be more interactions, means there will be negative deviation. So that is a negative deviation, means that is a maximum boiling azeotrope. Maximum boiling azeotrope. Right? What about bromoethane, chloroethane? The alkyl chain is same. The difference is in the halogen. Again, it is an ideal solution. Again, it is an ideal solution. No azeotrope. N-hexane, N-heptane. Everything is same. It's just the difference of one carbon is there. Again, it is an ideal solution. Right? So, answer is your B is your correct answer. That is water and nitric acid. Okay? Yes. Okay, Rohan, Pooja, everybody, Arjun. That is clear? Yes. B is non-ideal solution. Very good, Pooja. Very good, very good. A and C, D are ideal solution example. Very good. I want this kind of crowd in my class. Right? So, try to give answer. Right? The more you try, why I am live here? Right? Why I am live? Why I have not put it recorded? Why? The reason I am live here, because I want to know your answers. Otherwise, I would have put this recorded version. Right? I want to know that is there any problem that you guys are facing, right? I want to interact with you guys, right? Okay. So now, next question is, which of the following aqueous solutions should have highest boiling point, lowest freezing point, right? Now, remember this thing. All the colligative properties, right? We know that here they are talking about boiling point, freezing point. Everything is directly proportional to your I. That is your van 't Hoff factor, right? Now, what is this I? I is basically the number of ions dissociated or associated. Now, as such, we cannot see any association here. There is only dissociation of ions. This will be dissociated into, K positive and NO3 negative, that means 2 ions. This is non-electrolyte, this is a non-electrolyte. Urea is a non-electrolyte. This will only have one molecule, there is no dissociation, right? So it is only one molecule. What about Na2SO4? It will have 2 Na positive plus SO4 2 negative. That means it will have 3 molecules, 3 ions. This will have Na positive and OH negative, right? So it will have 2 ions. So maximum number of ions which has, right? Maximum number of ions which has. As you can see, 2, 1, 2, 1, maximum number of ions are in the B part, right? So here we can say that this will have maximum van 't Hoff factor. That is why highest boiling point and highest freezing point will be there, right? Very good, very good, very good. Urea has one, I value 1, right? Very good, very good. Yes, urea has 1 value, right? Okay, because there is no dissociation. It is a non-electrolyte. Very good. Next question is isotonic solution. Next question is isotonic solutions are solutions having same. Isotonic solutions are solution having same surface tension, vapor pressure, osmotic pressure, or viscosity, right? I'll give you one hint. This is related to colligative property, right? One of the colligative property is the answer for this. I'm looking for your answers in the chat box. I'm waiting for your answers. So, I'm waiting for your answers in the chat box. Yes, yes, yes. Very good, very good, very good, very good. C is the correct answer. Very good. So, that is your osmotic pressure. What is osmotic pressure? It is represented by pi equals to CRT. And what is this C? This C is called your molarity, right? This is called your molarity. Now, when your osmotic pressures are same, pi 1 is equals to pi 2, that is your isotonic solution. Isotonic solution. But for example, you have pi 1 is greater than pi 2, then we can write that the one which has higher osmotic pressure, that is your hypertonic, solution, and the one which has lower osmotic pressure is called the hypotonic solution, okay, which has higher boiling point is the hypertonic, not boiling point, the osmotic pressure, which has lower osmotic pressure is the hypotonic solution. This how you can remember, very good. How you can remember this? Very good, very good. How you can remember this? Hyper means someone who is very angry. When you are very angry, your energy is very high, right? So similarly, hypertonic, it has more osmotic pressure, right? Okay. Next is standard electrode potential. Now we are saying standard electrode potential of zinc electrode is this, right? For zinc electrode, the standard electrode potential is given to you, and that of silver is this. A very, very important question and a very tricky question as well, right? So it's a very important, and by the way, all the questions are important, but this one is tricky. You have to have a lot of knowledge, right? You need to have a conceptual knowledge to solve this question, right? And easily they can ask you this in your PUC, midterm, or your final board exam. They can ask you easily, right? Okay. So now let us see. They're asking that you have two things. You have Zn. You have Zn, that is minus 0.76 volt. You have Ag, that is your plus 0.80 volt, right? And they are saying if a cell is constructed coupling the two electrodes. I have one zinc and I have one copper electrode. I have constructed a cell here, right? Now they are saying which will act as a cathode, right? Now tell me one thing, how you will see this thing. A cathode is one where reduction happens. Right? That itself wants to get reduced. That means that wants to get reduced. I am, simplifying this thing for you. Cathode means where reduction is happening. That means reduction means which wants to get reduced itself, right? Wants to get reduced. Now, as you can see, the one which wants to get reduced itself. So what I'll do here, cathode reduction wants to get reduced itself. Now I'll see which has, which wants to get reduced. For that you need to know this one more thing. One very simple thing I'll tell you, right? Which has more reduction potential. Standard electrode potential means they are talking about reduction potential. Standard electrode potential means they are talking about reduction potential only. Now, which has more reduction potential, that has a tendency to get reduced. If this is positive, this is Zn negative. Now, which has more reduction potential? Ag has more reduction potential than Zn, right? Ag has more reduction potential than Zn. So, can I say if it has more reduction potential, it has more tendency to get reduced. It wants to get reduced. If it wants to get reduced, that means it will act as a cathode, right? So your answer will be Ag. Silver will act as a cathode. A is going to be the correct answer, right? Ma'am, A is correct. Anode oxidation happens. Very good. Anode oxidation happens. Cathode reduction happens. Oxidation, you have gain of oxidation, you have loss of electrons, and reduction, you have gain of electrons. And in oxidation, the simplest way is to see. In oxidation, oxidation number will increase. In reduction, oxidation number will decrease. Right? Okay. So, answer is your E is your correct answer. Next question. You have law used to determine the limiting molar conductivity of a weak electrolyte. For a weak electrolyte, we have a specific law. How you can remember this? Okay. Whenever India is playing weak, who helps? Virat Kohli. Whenever India is playing weak, like India is like almost like on that ground of losing things, right? Who is there to help India, right? Who is the captain? Who is the captain, right? Virat Kohli. So from that you can remember Kohlrausch law, right? Your law is very good. That is B is the correct answer. That is your Kohlrausch law. Okay, the pronunciation are different. People pronounce it differently. So I pronounce it as Kohlrausch law, right? So it's a very weird name, right? Do you agree? It's a weird name, ma'am. Yes, it is a very weird name. Yeah, these foreign people, they have very weird names. Yeah, isn't it? Yes. Very good. B, very good Arjun, very good Rohan, Pooja, Syed, very good, very good. Now, next is according to the equation. Now you have this equation, Cu2 positive plus 2 electron give rise to Cu. Now firstly just see the question, okay? Don't just directly answer it. See the question. This is also important question. This is also you have to have some conceptual knowledge. This question was still direct, right? You just need to know the name and you can directly answer it within 1 second. But this question, you need to have certain amount of conceptual knowledge to answer this question. Okay? So we'll try our best to answer this. According to the equation, this is the equation. How many moles of copper are deposited when this much coulomb of electricity is passed through a solution of Cu2 positive ion, and this 96500 coulomb is your 1 Faraday, right? Do you know what is basically 1 Faraday? 1 Faraday means 1 mole of the charge on 1 mole of electron. 1 Faraday, the actual definition of 1 Faraday is the charge of 1 mole of electron is 1 Faraday, right? So here, as you can see, you can just directly use a unitary method. For 1 mole of copper, or you can see 2 Faraday, or you can see 2 mole charge of electron is required for 1 mole of copper. For 1 mole of copper, you require 2. This is 1 mole, this is 2 mole, right? This is 1 mole and here it is 2 mole, right? So for 1 mole of copper, 2 mole of charge is required. So can I say what is 1 mole of charge is 1 Faraday, 2 mole of charge is 2 Faraday. So 2 Faraday charge is required for 1 copper atom, for the generation of 1 copper atom. But I want to use only 1 Faraday charge. So if I am using 1 Faraday electricity or charge, it will make 1 by 2 of copper, that is 0.5 of copper, right? 0.5 of copper, right? 0.5 of copper. So I'll write that answer is D will become my correct answer, right? D will become your correct answer, right? Is this question clear to everyone here? So what exactly we are doing here? We just saw this equation. We know that I am just applied the unitary method here, right? That 2 mole of charge is that forms 1 copper atom, right? 1 mole of copper atom. So 2 mole means 2 Faraday, means 2 Faraday is forming 1 mole of copper atom. That means 1 Faraday will form 1 by 2 mole of copper atom. That means 0.5 mole of copper atom is formed. That is your D will become your correct answer, right? Okay. Yes. Very good. Now next question is, identify the configuration of transition element which shows highest magnetic moment. Now you have to identify that which shows the highest magnetic moment. Very good, everybody in the chat box. Everybody in the chat box, identify the configuration of the transition element which shows highest magnetic moment. That means highest number of unpaired electrons they are asking. You need to answer the highest number of unpaired electrons. So if you want to answer the number of unpaired electrons, let us make the structure here. This is your D. Let us make 5 boxes here, right? And here you have 7 electrons, right? So firstly, singly filled all the D generate having the same energy, because these 5 orbitals have same energy. So firstly, singly filled all the orbitals, then 5 already done, then 6, and then your 7. So your number of unpaired electron is 3 here, right? And what about this one? Here you have 3D8. Here you have 3d8. Again here it will be 1, 2, 3, 4, 5, 6, 7, 8. Now your number of electron is 2. Now what about this one? You have 3d5. You have 3d5. Now here your 1, 2, 3, 4, 5. Number of electron is 5. Number of electron is 5. What about this one here? This is your 3d2. 1, 2, 3, 4, 5. This is your number of electron is 2. So this is your n is equals to 2. Right? So what you got, the correct answer, the highest number of electron is n is equals to 5. So B will have your highest magnetic moment, because magnetic moment is nothing. Magnetic moment is equals to mu is equals to under root n plus 1. Right? So if your n is greater, then your magnetic moment is also greater. Right? Okay? Then B will become your correct answer. Yes, students. Next question, again a very important question. Oxidation state of chromium. You have to answer the oxidation state. Ma'am, please explain the last question again. Okay. So students, as you can see here, this is your 3d7. You have 7 electrons here. So it will be 1, 2, 3, 4, 5, 6, 7. 3 unpaired electron. 1, 2, 3. So it is n is equals to 3. Here you have 2 unpaired electron. Here you have 1, 2, 3, 4, 5 unpaired electron. Here you have 2 unpaired electron. They are asking you the maximum dipole moment. They are asking the maximum magnetic moment. Magnetic moment is defined by mu is equals to n plus 2 Bohr magneton. So, if your n is greater, if your n is a number of unpaired electron is greater, your mu is also greater. So, number of unpaired electron is maximum in B part, that is 5. So, it will also have maximum magnetic moment. Right? Okay. Electrochemistry question. This one. Oh, this is very simple. See. You just see this reaction here, right? Apply the unitary method. This basically means 2 mole of electron you have. This means 1 mole of copper you have. Take the electron as atom only. So if this is an atom, so you will say 2 mole. Here you will say, because it is stoichiometry is 1, you will say 1 mole. So that means 2 mole of electron is forming 1 mole of copper. That means 2 mole of electron. 1 mole of electron charge is called 1 Faraday. That is the definition of Faraday. Right? So 2 mole of electronic charge means 2 Faraday. Right? 2 Faraday is equals to 1 copper atom. Now, but in the question they have given us when 1 Faraday of electricity is passed, what is the copper deposited? They are asking the copper deposited when 1 Faraday of electricity is passed. So when 1 Faraday of electricity is passed, you have to calculate the copper. So we are not talking about 2 Faraday, we want 1 Faraday. So I will just divide it by 2, it will have 1 by 2 of mole of copper, that is 0.5 mole of copper. Right? Okay? Yes, very good Pooja. Half-filled D block will show highest magnetic moment. Right? Okay? Next question, you have oxidation number. Right? Oxidation state of chromium in this and this. You have to find out the oxidation state of chromium. Very good. Now, you have K2Cr2. Should I write it on the next page or should I write it here only? Here only I'll write it. This is basically your two things, right? I'm defining it here. Right? This is your K2Cr2O7. And this is K2Cr04, right? So just see one thing. You want to calculate for copper, take you want to calculate for chromium, take chromium as X, right? So for potassium, it belongs to group number 1, so it is having +1. So +1 into 2, it means +2. It is 2 potassium you have, right? So it is +1 into 2, that is 2 plus 2x. Now you have 7. Right, that means +7 multiplied by -2 equals to 0. Why multiplied by -2? Because oxygen has -2 state, right? Oxidation state of oxygen is -2. Very good, very good, very good. 6, ma'am, very good, supreme soul, very good. So now this is your 2x, right, +2 -14 equals to 0. 2x -12 equals to 0. 2x is equals to 12 and x becomes your 6. So in your K2Cr2O7 potassium dichromate, the answer is plus 6, right? And what about this one? Here it is again it is 2 because of this, plus there is only 1x here. Here you have 4, so it will become plus 4 minus 2 equals to 0. So this is x plus 2 minus 8 equals to 0. So x minus 6 is equals to 0, x is equals to plus 6 again. So answer is your 6 and 6. So answer will be B is your correct answer. Yes, B option, ma'am. Very good, Rohan. Very good guessing master. Very good, very good, very good. Okay, Pooja, have you done some mistake? Otherwise, I was expecting answer. Right, don't worry. We have so many other questions as well. Right? Okay, Diksha ma'am, B question is correct. B answer is correct. Definitely B is the correct answer. Next question is your next question. Everybody ready for that? Ready to give me that answer? Okay. Atomic size of 4D. They are asking that atomic size of 4D and 5D series. Right? Very important question. 4D and 5D series elements are almost the same. What is the reason? So you have 4D series, you have 5D series. Like hafnium, zirconium, they have same size, right? That means 4D and 5D elements have same size. What is the reason? Reason is lanthanoid contraction, formation of colored ions, variable oxidation state, formation of complexes. Now what can be the possible reason for that? A option. Very good, Rohan. Very good, very good, very good. And very good, Arnold. Okay, very good, Supreme. Why you guys are not writing your names here? Huh? Okay. So, mysterious things. Huh? So, your 4D and 5D, because of the 4F poor shielding effect. Poor shielding, that is your lanthanoid contraction. That is your lanthanoid contraction. They have almost similar sizes. So basically what happens here, your 4F orbital, it's like a friend who is protecting you. For example, if you're talking about the shielding effect, S, P, D and then you have F. The shielding effect of this F orbital is very less. It's a very bad friend, right? You have nucleus. Nucleus is your parents. Okay. For example, this is your nucleus. Nucleus are your parents. And here you have the electrons. And here you have 4F, right? So, 4F is not able to protect the outermost electron from the attraction from the nucleus. Because nucleus is your positive. Nucleus is going to attract the outermost electron because this is positive, this is negative. In between, there is a shield, that is 4F. Now, this outermost electron is having a hope from 4F that it will protect it from the nucleus. But this 4F is not able to protect because it has a very low shielding effect. That is why the size will decrease because these electrons will get attracted to this nucleus and hence the size will decrease here, right? That is called lanthanoid contraction. Okay? Okay? They can also ask you which is more, lanthanoid or actinoid contraction. Actinoid contraction is more than lanthanoid contraction. It is more than lanthanoid contraction. Can you tell me the reason behind that? Because 5F is even bad friend. 5F is a very, very bad friend. He is such a loser. He is such a bad friend. He is not able to protect anywhere from the parents, right? Like, okay, I am going to this place. Okay, I will tell your mom. He is that kind of friend. 5F is that kind of friend. So 5F is a very, 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 very poor friend. Right? That is the reason he is not able to shield it. 4F is also not a very good friend, but at least better than 5F. That is why lanthanoid contraction is still better as compared to actinoid contraction. Yes? Okay? Okay. Arnold. Okay, I feel that's a very unique name. You have a very unique name. I thought that's such a foreignish name, right? Isn't it? Okay. Now, yes, Arnold, Arjun, Rohan, Pooja, right. So, now let us see this good example, ma'am. Okay. So, now examples, I will give you very, very unique examples. when after your midterms, we'll start preparing again, right? We will do complete chapters, right? When we'll start doing the complete chapters, right? So you are totally going to love everything that I'll teach you, okay? So now the next question is, NiCl4 2 negative and you have NiCN4 2 negative differ in which thing? One is low spin, other is high spin, whatever. Let us see both the complexes here. I am going to draw the complexes here, right? So one is your NiCl4 2 negative and next is your NiCN4 2 negative. I am going to draw everything on this, right? Okay, so it's a very interesting thing. Firstly, calculate the oxidation number of nickel. So this is x minus 4 is equals to minus 2, x will become equals to plus 2. Again, this is x minus 4 is equals to minus 2, again x is equals to plus 2. Because your chlorine and CN both are having minus 1 charges, both are negative ligands, right? So next thing is, what you will do, you will calculate what is nickel. Nickel is 28, atomic number is 28. So it is argon 18, 4s2, 3d8. That is the electronic configuration, right? Here nickel has electronic configuration argon 18, 4s2, 3d8. Now we are taking out 2 electrons from both sides, right? Here it is argon. Whenever we take out electron, we take out it from 4s. After that, we take out from 3d, right? Don't take it out from 3d first, right? Don't do this like this. 4s2, 3d6. Ma'am, tick. No, that is wrong, right? First, you take it out from 4s. So, it will be 4s0, 3d8. Here also, it will be nickel, that is 4s0, 3d8, right? So, it will become like this. Now, understand one thing. When you have 4 as the coordination number, 2 choices are there. Either it can have sp3 hybridization or it can have dsp2 hybridization, right? So, you'll see which hybridization it has, right? So, here if you talk about your chlorine is a no pairing ligand. There is no pairing because it is a weak ligand. But your CN is a strong ligand, so there will be pairing. So, there will be pairing, right? So, what you will do here, you will have this kind of thing, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. This is your S, this is your P, right? And this is also your D. 1, 2, 3, 4, 5. This is your S, this is your P, right? Right now I have just made boxes here. Now let us fill the electrons. There is no pairing. That means 8 electrons will not cause any pairing directly, right? So it will be 1, 2, 3, 4, 5. Once all the d orbitals are filled, after that start doing the pairing. 6, 7, 8. Right? Here you will have the pairing directly. It doesn't matter. You don't have to fill all the electrons firstly. So you'll do 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, whenever we are doing coordination compound, we are applying VBT to coordination compound, we will see how many boxes are completely empty. Right? So, this is half filled. We don't need half filled because each ligand is donating 2 electrons. So, we will look for completely empty because we need 4 empty boxes because we have 4 ligands here. So, this is sp3 and this is your dsp2, right? This will form dsp2, right? I have also written the hybridization. sp3 will form what kind of geometry? That is your tetrahedral. That is your tetrahedral, right? And dsp2 will form square planar. It is your square planar, right? The geometry is square planar, right? Another thing is they have asked you about low spin, high spin. What is a low spin complex? That has, you will say, less number of unpaired electrons. Right? High spin means it has more magnetic movement, it has more number of unpaired electron. That means less unpaired electron. Less unpaired electron. And here high spin means more unpaired electron. More unpaired electron. So can we say that here the number of unpaired electron is 2. Here there is no unpaired electron. When there are less unpaired electron, that is your low spin complex. That is low spin complex. And when there is pairing, when there is unpaired electrons, so that is called high spin complex. High spin complex. So we can write your Cl has high spin. Where is Cl? Where is Cl? Cl is high spin complex and this is your low spin. So B will become the correct answer. B will become the correct answer. How many of you got it right? Yes, everybody. 2 and 2. What is 2 and 2? What is 2 and 2? 2 and 2, 2 and 2. Acha, you're talking about the oxidation number, is it? You're talking about the oxidation number. Now, students, tell me, is this clear to everybody? It's a very, very important question. Very, very important question, right? Okay. So, this is based on your coordination compound VBT theory. Like a must question. I can guarantee that in your exam, you will definitely see a question based on this. I can guarantee this, right? Okay. Okay, students. So now, next is, so B will become your correct answer. Next question is MC bond in metal carbonyl possesses what kind of thing? Any idea about metal carbonyls? Any idea about metal carbonyls? They have a very special quality. What is that special, unique quality in the metal carbonyls? So these metal carbonyls have a very unique special quality. What is that? Very good. So basically what happens, this is your metal and this is your carbonyl, right? So we know that ligand is, because carbonyl is the ligand. So I am taking this as L. I am taking carbonyl as L. So what is the work of a ligand? Ligand is electron donor, right? So ligand will donate the electrons. Ligand will donate the electrons, right, through sigma bond. That is a usual thing, that ligand will donate the electrons and metal will accept the electron. That is a normal thing. But in weird thing, for example, someone has given you something, their notes. You will say, okay, for example, I am teaching you totally free of cost on this channel. We guys are teaching you totally free of cost, right? Okay, on this time, right? And we are here to help you. Now, one thing is, you're okay, ma'am is teaching us, it's fine, okay, cool, right? Doesn't matter. Other are those students who actually comment down, right? They are not those students who will just like, okay, you give us electron, we will accept it. No, 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 no. They have a synergic bonding. They have a love, right, with us, right? So what they will do, they will donate back those metal. Metal will donate the electrons. They'll be like, thank you so much, ma'am, everything. I see your comments daily. Yesterday also I saw all your comments on the live session about the naming reaction. I totally loved it, right? Because I am donating you the electrons, you're also donating me the electrons, right? Okay, so I am donating by sigma and you are donating by pi bonding. This is called your synergic bonding. This is called synergic or back bonding, So now they are saying MC bond in metal carbonyl possess ionic character, both sigma and pi character only, and dipole forces. So it has both the character sigma and pi character, sigma from this side, pi from this side. So it has both the character, that is sigma and pi character, right? Sigma is when ligand is donating, pi is when metal is donating. Now this is also important, when it is sigma, when it is pi. When ligand is donating, when the usual case it is sigma. When there is something abnormal, then that is called pi, right? That is called pi. So B will become your correct answer, right? Next question on your screen is, which of the following complexes exhibit facial and meridional isomerism? Now what is facial? What is meridional isomerism? Everybody in the chat box, I'll tell you what is facial, what is meridional in such a simple way, no? So you're totally going to love it. Firstly, I want to see your answers in the chat box. Everybody. I want to see your answers in the chat box. Yes. So, as you can see here, facial means on the face of the octahedral. This is the face, triangular face of octahedral. This is a triangle that it is forming. 1, 2, 3. It is a triangle that it is forming. As you can see, here you will have the formation of a triangle, right? Here you will have the formation of a triangle. Can you see this? Here you have a triangular face, right? This is another triangular face. How many triangular face you have here? 1, 2, 3, 4, right? And this is your 5, 6, 7 and 8. That is why it is called octahedral. That is why it is not called, it has 6 bond, ma'am. Why it is called octahedral? Octa means 8 because it has, because it has 8 phases, right? So now when on the face you have same atoms, on the face when you have same atoms, right? This is to make you visualize. I don't believe in like students cramming things, right? So this is on that phase, right? On that phase you have same atoms, that is your facial isomerism, right? So when we talk about meridional, meridional is also very interesting. First it was just see, on one phase you have same, on one phase you have same atoms, right? This phase also has same atoms, white atoms, right? Okay, so what is meridional? What is meridional? Meridional is when, I'll tell you, meridional is also very interesting, right? Meridional means when you can make a semicircle, right? When the same atoms are able to make a semicircle here. Can you see? They are able to make a semicircle. These same atoms are able to make a semicircle here. So that is called meridional isomer, right? And as you can see in this, I have 3 same atom and other 3 are same. So basically it is shown by your Ma3B3, right? So answer will be A is your correct answer. That is Ma3B3 is your correct answer, right? Okay. Yes, students. Yes, Pooja. Yes, Harishit, Arnold, and then Ane. Hanji. Okay. Understood this? Simple. Next is your decomposition of benzene diazonium chloride by using CuCl2. Now we have jumped to organic chemistry. So let us do organic chemistry questions as well with that amount of enthusiasm, and I want to see your answers in the chat box. Yes, I want to see your answers in the chat box. Decomposition of benzene diazonium chloride by using Cu2Cl2, HCl to form chlorobenzene. That means from benzene diazonium chloride, that means N2Cl. You want to make Cl, right? Simple this. Now they are saying that you have used Cu2. This I have done in the last class, right? This is a naming reaction we have done in the very good. That is your Sandmeyer. I have told you Sandmeyer. Why Sandmeyer? Sandmeyer, you can just understand that here your salt of copper you have used. Salt and sand are almost similar. So you can remember this, that the answer will be simple Sandmeyer reaction. Intentionally, I have taken very less questions from your naming reactions because I have already taught you naming reaction in the previous class. Those who have not watched it, go through that. You are totally going to love it, right? So I have taken only 2-3 questions so that you can see actually your book is filled with your MCQs of naming reaction. It is filled, right? You see, you check out all the PYQs, like past 10 years, you will see it is filled with naming reaction. That is why I have taken up a different lecture on that, right? Okay. Next is, so I have taken up some other question apart from naming reactions in your organic chemistry, right? So which of the following alkyl halides most readily undergo hydrolysis by SN2 mechanism? Now if you talk about SN2 mechanism, can you tell me what is this a 1-step or 2-step? When there is 2, that means 1. When there is 1, that means 2. So there is 2, that means it is 1 step. If there is 2, that means it is 1 step. 1 step means there will be formation of no carbocation. There will be formation of transition state. That means simultaneously, for example, you have any Rx, right? Simultaneously, what will happen? Here, the other nucleophile will attack simultaneously, right? And the bond will break simultaneously here, right? This is the transition state will be formed. So now let us see transition state. For example, you want to meet me, right? I'm already occupied with a lot of students. Will you be able to meet me? Be like, ma'am, here, there, everywhere you have students, ma'am, how I was not able to meet you, ma'am. I saw you in the market, but you were occupied with so many people that I was not able to meet you, right? This will happen, right? So, for example, there is no one, right? I am just there and you're like, hi, ma'am, I am your student. Then you will be able to talk to me. How? Because there is no steric hindrance. So, when we want transition state, in that case, we will focus on the steric hindrance. We will focus on the steric hindrance, right? We will focus on the steric hindrance, right? So, let us see which has least steric hindrance here, right? If we talk about this is a definitely a big no. This is also 2 methyl groups are here, again a big no. Here you have 2 carbons, here you have just 1 carbon. So this will have least steric hindrance. So answer will be CH3Cl, right? Very good. So answer is your B is the correct answer. Very good everyone. B is the correct answer, right? Okay. Now next question you have. Oh, have I written the right answer or what? Have I written the right answer here? No, right? Then why they have written D over here? This should be D. Okay, this should be not A, this should be D. This is your D part. Okay. Okay, now RCH double bond CH2, right? React with a diborane to give addition product. They are saying you have an alkene, right? You have an alkene, you have one alkene. Now this is your alkene that I have. This is your RCH double bond CH2. They are saying you are using diborane. Diborane means you have B2H6. To give addition product, this on treatment with hydrogen peroxide, that is H2O2, right? In the presence of aqueous sodium gives which thing? Very good, very good. A, you guys are saying. Okay, just tell me which rule will be applied here. Markovnikov or anti-Markovnikov? Markovnikov or anti-Markovnikov? Everybody in the chat box? Yes. So your anti-Markovnikov rule will be applied here, right? Anti-Markovnikov rule will be applied here. Anti-Markovnikov means you will have, if you want, if your negative part will get attached to the more number of hydrogen, more hydrogen, right? And positive part to less hydrogen. And your Markovnikov is opposite to that. In Markovnikov, your negative part gets attached to less number of hydrogen. It means rich to rich, rich to rich. Negative means a lot of electron density. More hydrogen means more hydrogen, rich. So rich to rich is an anti-Markovnikov rule, right? So when there is an anti-world, rich will help rich, right? But in a good world, in a Markovnikov world, when there is nothing anti against each other, then rich will help poor. That means negative part will go to less number. The one who is rich will go to poor person, right? So this you can remember these things, right? By this you can remember these things, right? So here you can just break this bond, and you will get R. This is not, by the way, how you break the bond, right? So I'm not going to do that because that is a different mechanism there, right? So I'm just going to write RC. This is H, one pi bond will break and to more number of hydrogen. Now, ma'am, what will be, ma'am, B, ma'am, what will be added here? So basically, this is nothing but the addition of H2O, right? That means you will have H positive and OH negative. OH negative is the negative part and H positive is the positive part, right? So to make alcohol, we have 3 things, right? We have 3 things. One is your acidic hydration, right? Other is your, this is called hydroboration oxidation, where the name, I think they have not written the name, hydroboration oxidation. This is hydroboration, this is oxidation process. Third is your demercuration, right? Demercuration, oxymercuration, demercuration, right? OMDM, right? So that is oxymercuration, demercuration, right? So here you will apply anti-Markovnikov rule. In the acidic hydration also you will apply, you will firstly form the carbocation, then apply the Markovnikov rule, right? And in case of oxymercuration, demercuration, you will apply Markovnikov rule, right? So that is the rule here. So here the answer will be A is your correct answer, right? Okay. Ma'am, when KCT preparation will start and the midterm exam on 28th and it completes on at 8 next month, please do preparation periodically, one chapter. Yes, don't worry Pooja, that we will start after your midterms, right? We know students are right now occupied with the midterms, but after that we are going to start with your KCT preparation, right? Okay. Yes. Now, next is this one, acidic nature of alcohol decrease in the order. Why I have not taught you this thing in detail? The reason be, because in not that much detail they will ask you in your board exam, but in competitive exam like KCT they can ask you, right? So we will do that in while we will preparing for KCT exam, right? So right now our focus is on the midterm. Acidic nature of alcohol decreases in the order, right? So see, if you're talking about 1 degree alcohol, that means here this carbon is attached to only one carbon. If you're talking about 2 degree alcohol, that means this carbon is attached to 2 carbons. If you're talking about 3 degree alcohol, that means this carbon is attached to 3 carbons. That is your 3 degree alcohol. Now, we know that if we want to see the acidic nature, I told you regarding the acidic nature of anything. For example, this is any acid, right? Positive, negative. This will be a good acid if it is able to make a stable carbon ion. If this is your stable, if after losing something you are still stable, then only you will lose that thing, right? So if after losing H positive it is still stable, then only it will be a good acid. So we will not talk about this alcohol, rather we will talk about the carbocation, carbon ion. So this is negative, here also this is your negative, here also this is your negative, right? Here also this is your negative, right? So this is your negative. Now let us see here what will happen. This is your CH3, CH2. It will start donating from one side. It is donating from two sides, right? Here the donation is from two sides. Here the donation is from three sides. Here as you can see the donation is from 3, because methyl group alkyl chain is a very good donation, right? So here the donation is from 3 sides. So more, I told you that take negative as stress, right? Positive as money. So negative stress means if you're talking about a carbon ion, right? If you're giving it more electrons, somebody is already under stress, you're giving it more stress, they will be unstable. So 1 degree will be the least stable. Then you have 2 degree, wait a minute. Yes, in 3 degree you are giving it maximum electron, right? Here also you are giving electron, but the electrons quantity is less. Here from 3 sides you are donating the electrons, right? So that means a lot of electron you are donating, a lot of stress you are giving. For example, your board examination, the syllabus gets spiked up, right? They increase the syllabus, then what will happen? You will be like, what is happening, right? So that is the reason your 3 degree will be least stable and maximum is 1 degree. So answer is A, 1 degree, then 2 degree, then 3 degree is the correct answer. Okay, 1 degree, 2 degree and then 3 degree is the correct answer, is it? Yes, everybody. Okay. Now, next question is oxidizing agent used in Itard's reaction for conversion of methyl benzene. I think I was thinking to give you, no. This was not your homework. Okay. So now oxidizing agent used in Itard's reaction. Here you converted toluene. Into benzaldehyde. This was a reaction where you converted toluene into benzaldehyde, right? So what was the oxidizing agent? Very good. Chromyl chloride you used here, right? In the presence of CS2. We used chromyl chloride. So this is your oxidizing agent. So C will become the correct answer, right? Next is iodoform reaction. Again a very predictable question, okay? Again a very predictable question, right? From here also the questions are repeatedly asked. Iodoform reaction with NaOI can be used for detection of which compound? So it's not like you will use it for aldehyde or ketones. Basically, for a carbonyl compound, if you have this kind of group, then it will show positive iodoform test. Then it will show positive iodoform test. And what is iodoform? That is CHI3, which is of yellow color. Which is of yellow color, right? Which is of yellow color. So where you can see this particular group, in this though we cannot see, in this we can see, in this also we cannot see, in this also we cannot see. This is C double bond OH, this is C double bond H, and this is your CH3, CH3, CH3. Yes. So here also it is not showing, right? So answer is your B will become your correct answer, right? Okay, B will become your correct answer for this. Which lesson this question from? This question is from your aldehyde ketones and carboxylic acid, right? Okay, understood? Next question is sodium benzoate. Sodium benzoate on heating with NaOH and CaO gives which thing? Now, what is this NaOH? This is your soda lime. This is basically soda lime decarboxylation, because this is your soda, right? And this is your quick lime. And this is your quick lime. So, when you use these two things with your any salt of carboxylic acid, right? So, you have sodium benzoate, that means you have this thing, right? You have COONA, right? When what you will use here, you will use NaOH and you will use CaO. So what will happen? It will take out this carbon dioxide, it will take out this Na, right? And it will form this kind of compound with one less number of carbon, and hence your benzene will be formed here. So answer will be your D is the correct answer, right? Students, usually what the difference? Yes. Who has answered A? Right? No. This is your sodium benzoate, right? So basically this reaction is called soda lime decarboxylation. Soda lime decarboxylation. Right? So in this soda lime decarboxylation, these are the reagents that you have, right? For example, you have anything. You have RCOONA. The task is to convert it into RH. Now you had benzene CONA, that is why this whole thing will be replaced by hydrogen, and hence you will have the formation of benzene here, right? And hence you will have the formation of benzene here. So answer is D will become the correct answer, right? D will become the correct answer, isn't it? Yes, everybody? Okay. Okay. Now, next question is, HVZ reaction takes place in presence of which thing? HVZ reaction, Hall-Bohal-Zelensky reaction. This will break miss. Students, we are about to end the session, right? So, we are just left with 2-3 questions only. HVZ reaction takes place in presence of which thing? Is it Cl2Br2 sunlight, Cl2Br2 red phosphorus, CCl4 or Fe? This is they are talking about that reaction in which, for example, you have CH, for example, this is R and this is CH2, this is COH. So in this, what will happen? Your alpha hydrogen will be replaced by the halogen, whatever halogen you will use, right? And the reagents here are Cl2 or Br2 red phosphorus. So B will become the correct answer, right? B will become the correct answer. So that is your correct answer, right? Okay. Now, I think the next 2 questions are for your homework itself, right? I have given you homework only, I feel. Oi hoy. So, next 2 questions are your homework. That is your, this question, this is your homework number 1. That is your homework number 1, right? And that is your homework number 2. Now, all the students take the screenshot of this one. Very, very good evening. Very, very good evening, Sneha. So, take a screenshot of this question. Acyl chloride is hydrogenated over catalyst palladium on barium sulfate. This reaction is called Rosenmund-Stephan, Wolf-Kishner, Clemenzin, right? You have to answer me the answer for first question, right? Now take the screenshot of this one. I will be waiting for your answers in the comment section, okay? I'll be waiting for that, right? Please provide PDF, ma'am. Yes, I'll provide you PDF. The PDF you will see on the Telegram channel, right? And the Telegram channel, the link is in the description, right? So you can subscribe to the Telegram channel and then you will get all the PDFs, right? So this is the first question. This is the second question. And here benzene is converted to benzaldehyde by treatment of COHCl in presence of anhydrous ClCl3. This reaction is called Itard, Rosenmund, Gattermann or Stephan, right? So I'll be waiting for first and second answer in the comment section, and I'll see how many of you actually comment down and how many of you try to answer this, right? Okay, I'll be waiting for your comments and I'll see, and I'll name those students who actually do their homework, okay? Yes? Okay, students, balance competitive exams. Students, right now just focus on your midterm. Don't worry, I am here, okay? Just subscribe to this channel and do whatever we are asking you to do, okay? Do all the reaction, do all the attend all the classes, all the videos, all the recorded session as well. Watch that, right? Why? Because we have, I have selected these questions for you. So it's not just 1 hour. It's basically 2 hours before I have taken out this content for you, right? And one more thing is coming here for you on the recorded version. That is tomorrow, right? You will get the physical chemistry revision, right, of your solution of electrochemistry and chemical kinetics, right? So you will get the revision of these 3 things, right? Okay, I think chemical kinetics is not in your syllabus, is it? No, that is not in your syllabus right now. So I'll not do for chemical kinetics, but yes, I will do for solutions and electrochemistry, right? I'll do the revision for solutions and electrochemistry. You will get your video, right? As well as I have handwritten all the notes, all the summarized notes I have made for you, right? So tomorrow you will get that video. Watch that and I'll be waiting for your beautiful comments in the comment section. Okay. Okay then, bye-bye. Take care. See you all in the next class. Till then, also share this channel with your friends. Share this channel on your groups to your juniors so that we can also help those students as well. And also, the more you share, the more you like, the more you comment, right, the more visibility it will be and the more we will be able to help you guys in your KCET, in your midterm, in your PU exam, everything we can help you, right? Okay? Okay then, bye-bye. Take care. See you all in the next class.